Good afternoon. My name is Riaan LOURENS, and I represent a company called Kelpak International. Now, the main activity of this company is to produce a seaweed product that's sold in agriculture across the world. I would like to touch on different seaweed sources that's used in agriculture, and then I would like to go into the actives that's found in seaweed products, and then I'll conclude with some of the results that we found with our seaweed product called Kelpak. Okay, when we look at seaweed resources around the world, the most prominent seaweed species that you will find is Ascophyllum nodosum. The reason for that is the abundance that you have. You have it on the North American East Coast, you have it on the British Isles, and then you have it on the coasts of Europe. You can also find Macrocystis species, which is quite dominant on the west coast of the United States. You have Durvillia species that you find in the South American coast and then also southern part of Australia. And then the seaweed species we use, Eclonia maxima, you find on the southern tip of South Africa. Now, I show some images of the different seaweed species, and just looking at the morphology of that, you can see that there is quite big differences just in the appearance of the seaweed. Now, if you would compare a seaweed from the same seaweed species, you are going to get differences. As I like to use a comparison, if you would use grape as a source, you can have either wine or you can have vinegar. And it's got different activities, it's got different purposes in life, but then it's also produced in different ways. Now, if you look at seaweed species from seaweed products from different seaweed species, obviously already you have morphological differences, and then as you process it, you will get differences. It's like comparing, for instance, a grape with an orange. You're going to get different end products. So what we do is we do an extraction. We mince up the seaweed, and then we put that seaweed under a very high pressure. Under that high pressure, the cell walls are being compacted, and then you have a sudden release of that pressure, which causes the cell walls to expand so rapidly that it actually ruptures. But within the cell, you also have organelles. You have your mitochondria, you have chloroplast, you have the nucleus. All of that's surrounded by membranes, and all of that could encapsulate some different active ingredients. Also, those membranes are being ruptured, and therefore you have a release of all the actives that you could find in the seaweed itself. What we did initially is we did a bioassay where we look at a rooting effect. A rooting of plants are very synonym with having auxins, the growth regulator auxins. And so for many years we thought that our seaweed product, because of this rooting effect, is auxin-based. However, in more recent times, we got access to a laboratory in the Czech Republic, and there they did scientific analysis of the product, and they found that there was hardly any auxins in the product, and so we had to go and look for other actives. So where initially we thought it to be auxins, it was not about auxins, it was about other actives, which I'll delve into right now. Okay. When we look at alginates, now what is an alginate? When you touch seaweed, it's got a slimy feeling to it. That is the alginate that you find in seaweed. If we compare our analysis of our product with alginates and we compare it to other products that's also made from the same seaweed, we find that we have a higher level of alginates. So when we look at polyamines, this was one of the new actives that was found by the Czech Republic, is also when we compare it to competitors of the same seaweed species, we find that we have higher levels, but also when we look at Ascophyllum nodosum products. Remember, I said that most of the seaweed products in agriculture at this stage comes from Ascophyllum nodosum resources. We found that we had higher levels of polyamines. Now, polyamines are compounds that are associated with the negation of stress. When you apply polyamines to plants, plants become more resistant to stress. Okay, so we also looked at the compound ecol, which is a fluorotannin, also referred to as polyphenols. Now, when we compare this to other seaweed resources, we found that a product called Afrikelp made from the same seaweed species than us at a lower level. When we look at Acadian, which is an Ascophyllum nodosum product, we had similar levels. And then when you look at a Durvilia species and another Ascophyllum nodosum product, we find that those products have lower levels of these compounds. Now, together with our research, a publication became available, and in this publication they looked at auxins, they looked at cytokinins and abscisic acid, and what they basically found with all these seaweed products on the market that they analyzed, that there was insignificant levels of these compounds in those seaweed products. I'm just highlighting the two South African products that's made from Clonia maxima. But really insignificant levels of auxins, cytokinins, and abscisic acid. So in this whole process, we had a bioassay that showed us that we have auxin-like activity. So we also got access to a bioassay that shows cytokinin-like activity. And so also in this bioassay, it showed that our product Kelpak had this kind of activity, even though it was found that there are no significant cytokinins in the product. It just tells you that there are other actives within the seaweed that gives you similar responses. So when we look at the actives, many can be listed. For me, the fluorotannins stand out and the polyamines. That is really what makes our product Kelpak work well. Last year, a publication also came out by EBIC. It's the Biostimulant Coalition of Europe. And they indicated that there are, according to their studies, there are not significant levels of plant growth regulators in seaweed products. And that it really is about other compounds. It's complex carbohydrates, and what they also specifically named was the fluorotannins, which we also have in our product. So it's just a confirmation that seaweed is not about the old view that it's about plant growth regulators. Just to share with you some results that we have on crops that's relevant here in Moldova, we can look at cherries. As what we've done, we use cherry pollen, and we actually germinate that pollen artificially. And if you have Kelpak in that medium, we find that we get better pollen germination and then also better pollen tube elongation. Excuse me. And of course, when you get better pollen tube elongation, the chances of that pollen to reach the ovule and cause fertilization is better. So Kelpak plays quite an important role in fruit set. And in crops where you struggle to get fruit set, it's a very useful tool to improve that fruit set. The most recent trial that was done in cherries was done in Italy. Oh, thank you. Where we applied Kelpak 4 times during the season, during a flowering stage, and then again at the change of color, and also once more about 7 days later. So we found a significant increase in fruit set. We found that even though you set more fruit, there was a slight increase in fruit size. And then when you look at your yield, there was a significant increase obtained with your Kelpak program. So here I'm giving an overview of more globally. We've done trials in California where we get the Kelpak program to give a significant increase. We've done trials in France. In this case, Kelpak applied 3 times during the flowering stage. Trials in Chile where Kelpak was applied during the flowering stage and then again at the straw stage, the change of color, and some time later as well. And then most recently, a trial in Italy, which I've already showed you the results. So when we look at literature, they mention that the application of polyamines to cherries will actually increase the fruit set. And if you look at the concentration, it's actually 100 parts per million. It's quite a low level that causes the significant effect. Then also, if you look at, you've increased fruit set, is how do you affect the quality of the fruit? We found that the firmness was not negatively affected. And then if you look at the sugar content actually was lifted significantly with the polyamine putrescine, which is the most prominent polyamine that you find in Kelpak. Excuse me. Now, if we look at results in table grapes, I know that table grapes is quite an important crop here in Moldova. This is just the image that shows an effect on autumn crisp. Now, autumn crisp is a variety that already has a fairly big berry, but there's a problem that you get uneven sizing. Now, if you apply your Kelpak program, you actually increase that berry size, but you get a very uniform berry size throughout your bunch as well. Excuse me. Now, this graph is just sort of an overview of what we get worldwide. Our product is a very prominent product being used in table grapes. And so I'm just showing some results from across the world. You have trials from Chile, you have trials from the USA, from South Africa, and then also Italy. Now, the most important application of our product to improve table grapes would be at fruit set, repeated 2 or 3 times. And then in the case of colored grapes, red grapes, black grapes, we also see a more uniform color development if we apply at veraison and 10 to 14 days later. Now, this is an interesting trial result. Here we applied Kelpak to table grapes at 2 to 5 centimeter shoot growth. And what we find with this is that the rachis of the bunch becomes elongated, and not only the length of the bunch, also your shoulders, your side branches actually show an elongation. Now, if we look at Kelpak in plums, here is a typical trial that was done in Chile. We find that application at the flowering stage and repeated several times, we get less fruit drop. When the natural fruit drop of plums happen, the Kelpak treatment actually reduced that. And now there's more fruit on the tree, and the tendency normally if you have more fruit is that it affects the size. The size is not improved that well. What we found is with this reduction in drop, we still showed an increase in the fruit size. If we look at some trials on peaches, that's again a trial that was done in Chile. Kelpak was applied 3 times, and here it was applied at a later stage. It was applied 45 days before estimated harvest, 30 days before estimated harvest, and 15 days before estimated harvest. So we got an increase in yield in our first pick, also the second pick, and when you look at the average over the 2 picks, it was almost 14% yield increase. If we look at application on apples, we've done trials in Germany, trials in South Africa, and also more recently trials in Italy. And in all cases, the Kelpak program gave us an increase in yield. If you look at the Italian information, those were achieved with only 2 applications. If you look at the German trials, that was 3 applications, normally applied at fruit set and then repeated twice more, 14 days apart. In South Africa, we did the 3 early applications, but we also followed up with applications when you get the change of color, and that gave us additional positive yield effect. So when you look at seaweed products, you need to find out what the manufacturers are telling you. What are their claims? What does the product produce in a plant? And then secondly, that company needs to also supply you with information that proves that claims. And then lastly, if you are into organic production, you need to know whether that product is organically approved or not. In our case with Kelpak, certainly we have organic accreditation. So with that, I'm at the end of my presentation. Thank you so much.